Okay, right angle trigonometry. Right? So you probably did a little bit of this in your geometry class, and where you learned some of the basics of the right triangle trigonometry. First of all, a trigonometric function is a function whose rule is given by a trigonometric ratio. And what that ratio does is compare the lengths of two sides of a right triangle. There are actually 6 trigonometric functions: sine, cosine, tangent, cosecant, secant, and cotangent. And we are going to look at all 6 today. But first of all, we're going to start with the 3 most oftenly used. And if you look at your calculator, they're the 3 that are on your calculator: sine, cosine, and tangent. And so these are used more than any other thing because of their easy access. When I was in school, we didn't have a calculator like you have. I mean, actually, there were some scientific ones, basic ones, but we used tables in the back of our book with all these numbers in them. So for you, you can just type stuff in your calculator and get answers, where back in that day, a long time ago, they had to put actual tables in the back of the textbook that people could look up numbers and find them. I don't even know, they might still be in the book. But anyway, so we've got sine, cosine, and tangent, and sine is defined, and when we write the sine of an angle down, we put it like this. So it would be sine of theta, and all theta is a Greek symbol that is used quite often to refer to an angle or the angle measure of something. Okay? So this says, even though it looks like sin, it's not sin. We say that's the sine of theta is equal to 4/5. And sine is defined as the sine of an angle is the ratio of the length of the opposite side leg to the length of the hypotenuse. So one thing when you're looking at triangles, and we're dealing with right triangles, you always want to be able to identify right away what is the adjacent side, what is the opposite side, and what is the hypotenuse. Now, the one thing is the hypotenuse is always the longest side of the right triangle, which means it's across from the right angle. The adjacent side and the opposite side depend on which angle we're talking about. So if we're talking about this angle here down in the left corner, then the opposite side, the side that's across from it, would be the 4. And the adjacent side would be the side that's next to it. So you can always think of it this way: the angle you're looking for, or you're looking at, the adjacent side and the hypotenuse always form that angle. So if I was talking about the other angle, this angle up here, okay, then the 4 would be the adjacent side and 3 would be the opposite. So it just depends on which angle you're talking about. So we're looking at theta down here, and so the opposite side is 4 and the adjacent side is 3. So we would say that sine of theta is equal to 4/5. And we say that sine is equal to opposite over hypotenuse. Cosine is equal to adjacent over hypotenuse. So that's the side, the length of the side that's adjacent to the angle over the hypotenuse. And tangent is defined as the opposite over the adjacent. And so some people memorize them, in which you're going to need to do. And they use a little, I don't know what they call those things, word thing to be able to remember different stuff. It's like PEMDAS for the order of operations, and some people remember these by just writing out the initials for each of the letters, and they call it SOHCAHTOA. SOHCAHTOA. SOHCAHTOA, which is sine is the opposite over the hypotenuse. Cosine is the adjacent over the hypotenuse. And tangent is opposite over adjacent. So that's the symbolism that some people use to remember those ratios. And you'll be using them a lot, so you should try to remember them, and we're actually, on Thursday, you're actually going to have a short quiz that basically involves the memorization of them. Okay? Adds a little bit more to it than that, but that'll be part of the quiz. It's just memorizing them. All right, so what we're going to do is we're going to first of all just take a right triangle and write down those three different ratios for them. Now, when we're working with these ratios for sine, cosine, and tangent, unless it tells you otherwise, always just leave it as a fraction. Okay? So here they want us to find the sine, cosine, and tangent for theta. So I'll write down the sine of theta equals cosine of theta equals and the tangent. Okay. And these is always the symbols you use. You put SIN for sine, COS for cosine, and TAN for tangent. Don't write out the whole word. Okay. This is the appropriate way to write it, and this is the way you'll see it on your calculator is SIN, COS, and TAN. Okay. So we're talking about this angle theta here. So the adjacent side always helps make the angle. So in this case, this side here is adjacent because the side that's 24 and the side that's 25 form the angle. The longer side is always a hypotenuse. So this side over here would be the opposite side. So one thing that you might always want to do is, first of all, you should always put the triangle on your paper. Okay? If it's a problem that involves a right triangle, draw it out. Make a sketch so that you can see a picture of what you're looking at. And then it's not a bad idea to list them as adjacent, opposite, or hypotenuse for a little while, at least until you're used to being able to pick them out. So in this case, it says sine is opposite over hypotenuse, so that would be 7 over 25. Like I said, we just write it as a fraction and leave it that way. Cosine is adjacent over hypotenuse, so that would be 24 over 25. And tangent is opposite over adjacent, which is 7 over 24. All right, so what are they for? There are some special right triangles. Did you have mixed up too? Okay. Special right triangles that we'll be using quite often, and actually we use these things a lot. And those two special right triangles are 30, 60, 90 right triangle and a 45, 45, 90 right triangle. In here we've put, looking at those two, that the 30, 60, 90 right triangle has this horizontal side here, which is the adjacent to the 30 degrees, is the square root of 3. The adjacent side to the 60 degrees is 1, and the hypotenuse is 2. And then for the 45, 45, 90, we know that since those two angles are 45 degrees, they're the same length. So those are both 1, and the hypotenuse would be the square root of 2 then. And so from those two special right triangles, we also have ratios for sine, cosine, and tangents that go with them. And we will use those a lot, and actually you're going to have to memorize them. And we're going to do this thing called the unit circle, and we will take advantage of all of those numbers to build this thing called a unit circle, and that you will memorize and have to be able to put down on paper for me. And you can ask all your pre-calc friends that you know, and they'll tell you all about it because they did it last week. So if you take pre-calc, you'll get to do it again. So these are ones that you'll want to put some of this down, at least the two right triangles and like that, so you can find them. But we're actually going to use that too, and that's in your book, so you'll want to write that down later then, but just keep your book open to there if you have it open. So they want us to use the special right triangles to solve some information about triangles. So here we're going to find missing side lengths. And we have this triangle here, that this angle here is 30 degrees. We have a side that's 74, and they want us to find the side that's x. So the first thing, whenever you're solving a right triangle or finding missing parts from a right triangle, you need to identify what are the things that I know, and so then which of those three trig functions, sine, cosine, or tangent, do I need to use to find that missing part? So we know this angle here is 30 degrees. The side that's 74, what side of the right triangle is that then? What? That is the hypotenuse. It's across from the right angle, so it's the hypotenuse. Okay, here's the right angle. It's across from it, so that would be the hypotenuse. Side x then, and so you can, if you need to, like sometimes the triangles aren't written in a way that, or aren't expressed in a way that I really like, and if you would prefer to redraw it, if that would help you, then you can always do that also. Because maybe sometimes it'll help you to see that that is definitely the hypotenuse. It's across from the right angle. So if this is my 30-degree angle, then side x here is going to be what? Is that the opposite or the adjacent? Side x, is that the opposite or the adjacent? Yep, of 30. Okay, it's the opposite. It's not forming the angle, it's across from the angle, so this is the opposite side. Okay? So we have a triangle where we're going to work with opposite and hypotenuse. So which one of those three trig functions then uses opposite and hypotenuse? That's sine. So the sine of theta equals the opposite over the hypotenuse. Okay, so I'm going to write it down. And then I'm going to replace everything with what I know. Well, the angle is 30 degrees. So we have the sine of 30. The opposite side we don't know, so we'll put an x there. And the hypotenuse is 74. Now at this point in time, we're not going to use our calculator because whenever we have an angle from our special triangles, we're always going to use the exact value. Okay? So in this case, we know what the sine of 30 is. It's an exact value. But since Lauren started punching numbers in her calculator, I want to remind you something. So make sure you have your calculator in front of you anyways. And go to the mode section of your calculator, because it's very important that you're in the correct mode, because if you're not, you'll get answers wrong. And that's not a good thing, especially if there's a bunch of questions that involve using your calculator. Okay? So we look down to the third line here on your calculator where it says radians and degrees. Okay? Radians and degrees are two different ways of measuring angles. Okay? Now right now, if it says 30 degrees, that means my calculator should be in degrees. Okay? So the first thing you should do is make sure that your calculator is in degrees. Okay? And quite often it's important that you should go back and check it. So really every day when you come in here, you should or you start working on these problems, you should check your mode right away and say, okay, is it in degrees or not? Because I want to make sure it is. So, okay. All right. So sine of 30, do we know what that is? Yes. Sine of 30 is up here in under sine. It says sine of 30 degrees is equal to 1/2. So I'm going to replace the sine of 30 with 1/2, and then I'm going to solve this equation. So I'll multiply both sides by 74. And we get to x equals 37. And at that point in time, you could have cross multiplied also. Yep, either way. So whenever we're trying to find a missing part of a right triangle, we need to figure out what parts do I know, so then I can figure out which trig function am I going to use. Substitute things in, and then solve the equation. Okay, so here we have a construction application, and you can see that I put a little caution here, just to remind us to check the mode of our calculator to make sure that it is in degrees, something that we did already. Okay. So most of the time when we're working with things, or a lot of the time, we don't have exact angle values. We don't have exact 30 or 45 or 60. Those come into play sometimes, but they're not all of the time that it happens. So we have to use our calculator. So here we have a water skiing competition. A jump ramp has a measurement shown. As to the nearest foot, what is the height above the water that a skier leaves the ramp? So always when you're doing problems that involve trigonometric ratios and right triangles, the first thing you should always put on your paper is the picture. Draw the picture on your paper. And then label those sides. Label everything, okay? What do I know? Do I know opposite? Do I know adjacent? Do I know hypotenuse? And they've been pretty consistent with us so far, but it'll change. So if I redraw this, here's my 15.1 degree angle. Here's my right angle. So this is 19 feet, and that would be which side of the right triangle? The hypotenuse, okay? It's across from the right angle, so this is the hypotenuse. This horizontal side here, okay, since that helps make this 15.1 degree angle, that's the adjacent side. And the height that I'm trying to find over here would be the opposite side there. So since, once again, I'm dealing with opposite and hypotenuse, we're going to use the sine. Sine of theta is equal to the opposite over the hypotenuse. So replace theta with 15.1 degrees. The opposite side in this case is h, and hypotenuse is 19. So now what I'll do then is 15.1 degrees is not an angle that we know the sine of. So we'll go ahead and multiply both sides by 19 because we need to get that 19 out of there. So to find h, in this case, it says we're going to do it to the nearest foot, so we'll find the approximate answer first and then write our actual answer down. So we'll go to our calculator. And we'll just take and we'll do 19 times the sine of 15.1. Hit enter. So this is 4.95 feet. So they want to know to the nearest foot what is the height above the water. So the ramp is 5 feet high. Okay, so even though still in this one, we're using sine again, the difference is that they don't give us the hypotenuse in this case, they give us the opposite. Right? So you have to remember that still we need to get that variable out of the denominator. So we're going to multiply both sides by L. So we get, oops, I guess that should be 12. So we have L times the sine of 17 equals 12. So in this case, we've got to divide by the sine of 17. Now let me ask you this. Is L going to be larger or smaller than 12 inches? Okay. And why is it going to be larger, Jenny? Yeah, it looks bigger, okay? Now, looking bigger doesn't mean anything, okay? Because I could draw a triangle completely wrong. And it could look smaller. Exactly, okay? The hypotenuse is always the longest side, so it needs to be bigger. And they've drawn this pretty well to scale with a 17-degree angle. So, but the one thing is the hypotenuse is always the longest side, so there's a way to kind of check myself to make sure I'm on the right track. So then I'll take my calculator, do 12 divided by the sine of 17. And we get 41.04 inches, and it says to the nearest inch, so L is approximately 41 inches. And in reality, it should be quite a bit longer, right? Because if the 12-inch side is across from just a 17-degree angle, that's not a very big angle. So that means that the hypotenuse is going to be quite a bit longer in this case. All right? So let's look at another one. Okay? All right? Here we have what's talking about the angle of elevation and angle of depression. Now, here's how I tell the difference. Angle of elevation is when you look out, okay? So we look into the horizontal and we look up, it's an angle of elevation is formed, okay? So if I look out across the horizontal with my eyesight and look up, it forms an angle of elevation. If I look out along the horizontal and then look down, it forms an angle of depression. So the angle of elevation here is formed by looking out and up, from the horizontal and up. The angle of depression is formed by looking out along the horizontal and then looking down. Okay? But notice something about these two angles. Anybody know anything unique about them? They are the same. Do you know why mathematically they're the same? What? That's one word for it, but there's a specific geometry terminology. They're not corresponding. They are alternate interior angles. Yep. Right. They're alternate interior angles because those two lines, the two dotted lines, are parallel in this somewhat straight line I just drew. And if here's a, so if I made those right triangles, okay, because, well, the horizontal lines are parallel, and they're on the opposite sides of the transversal there, so they are alternate interior angles, and they're equal. Okay? But the difference is just talking about what is angle of depression, what is angle of elevation. So here we have a biologist whose eye level is 6 feet above the ground, measures the angle of elevation to the top of a tree to be 38.7 degrees. If the biologist is standing 180 feet from the tree's base, what's the height of the tree to the nearest foot? So the first thing we always want to do, this is where if you're have artistic ability, you can actually make some pretty cool drawings, okay? I don't have artistic ability, so I make pretty drawings, but they get the point across, hopefully. All right, so we have this person standing here, all right, my stick guy, and he's looking over at a tree. Right? So over here we got our tree. And so he is looking up at the top of the tree. And so I can make a right triangle here with, according to this biologist looking at a tree. They tell us that his eye level is 6 feet tall. Right? So this is important, and we'll talk about that why in a minute. That's 6 feet. Says the angle of elevation is 38.7 degrees, and he's 180 feet from the tree. And they want us to find the height of the tree. So they want us to find this side of the right triangle plus this additional 6 feet to get the height of the tree. Okay, does that drawing make sense then? So if we look at the triangle then, here's my angle here at 38.7 degrees. This horizontal side of that triangle helps form the angle of 38.7 degrees. So this is the adjacent side. And the part that gives me most of the height of the tree is the opposite, because it's across from that angle. The one thing we don't know, and we don't care in this case, is the hypotenuse. So which one of the three functions works with opposite and adjacent? Which one? Tangent. Okay? So tangent of an angle is equal to opposite over adjacent. So we have the tangent of 38.7 equals x over 180. So to find x, we multiply both sides by 180. So x is approximately 180 times the tangent of 38.7. So 144.2 feet. Okay. That's the length of x. So it says if the biologist is standing 180 feet from the tree's base, what's the height of the tree to the nearest foot? So we need to add 6 to that for the height of the biologist. So the tree is approximately 150 feet tall. Okay. Yep, there's one more. Okay. So once again, a good sketch is really important for your success in being able to find the answer. So you make a good sketch of it, identify what I know, figure out which trig ratio it is you're going to use, okay, and then solve that. Okay. Last one, then we're going to look at the other 3 trigonometric functions. So there are 6 trig functions, sine, cosine, and tangent. The other 3 trig functions are cosecant, secant, and cotangent, and they're called reciprocal functions because they're the reciprocal of the first 3. And remember, when we're finding reciprocals, we just flip them over to find the answer. So you can see that the lettering they use, cosecant, is CSC, and that's the reciprocal of sine, so 1 over sine. So where sine is opposite over hypotenuse, cosecant is hypotenuse over opposite. Secant is the reciprocal of cosine. So secant of theta is equal to 1 over cosine, which is equal to hypotenuse over adjacent. And then we have cotangent, which is the reciprocal of tangent. So that's adjacent over opposite. So whenever you have a problem that asks you to find all 6 of the trig functions, which you'll have this a few times, that what I would always do is vertically write down sine, cosine, and tangent, and then right next to them, like in the second column then, write down cosecant, secant, and cotangent. So you put the reciprocals next to each other so it's easy to flip over your answer. Okay? All right, and we'll do that when we do this problem. All right, and if you look back at the triangle we used in example 1, you could see that it was still that same 3, 4, 5 right triangle, and all of those numbers were just flipped over. Okay. All right. So we want to find the values of the 6 trigonometric functions for theta, given that we know these two sides of 24 and 70. And we're missing the side, right? We're missing the hypotenuse. Can I find the hypotenuse? Yes, you can. We can find it by using our wonderful friend, the Pythagorean theorem. So 24 squared plus 70 squared is equal to, we'll call it C, the hypotenuse squared. So before we can do anything else, we've got to find that third side of the triangle by using the Pythagorean theorem. A squared plus B squared equals C squared. So C is equal to the square root of that. So what is C equal to then? 74. Okay. So this side is 74. And that is our hypotenuse. Okay, Michelle, which one is the opposite then? 24 or 70? Is 24 across from the angle, or does it help make the angle? Okay. All right. Well, I'm asking to help you. Okay. All right. 70 is the opposite. Okay. It's across from the angle. 24. Okay. And here's the thing. What two sides make that angle? Okay. The adjacent side always forms the angle with the hypotenuse. Always happens that way. Okay. So when I'm going to find these 6 trig functions, I'm going to write down sine of theta equals, cosine of theta equals, tangent of theta equals. Find them, and then I'll do the reciprocals. Cosecant is the reciprocal of sine, so I'm going to put it across from it. Secant is the reciprocal of cosine, so I'll put it across from that. Cotangent is the reciprocal of tangent, so I'll put it across from that. Now make sure you're always putting theta, okay? Don't just put COT, SIN, like that. You have to put the angle that we're talking about now. Okay? So sine is opposite over hypotenuse. So 70 over 74, which is 35 over 37. Cosine is adjacent over hypotenuse. So 24 over 74, which when I reduce that, I get 12 over 37. And tangent is opposite over adjacent. So 70 over 24, which is 35 over 12. So then to find the other 3, I just take those 3 and do the reciprocal. Okay. Cosecant is the reciprocal of sine, so that would be 37 over 35. Secant, reciprocal of cosine, would be 37 over 12. And tangent is reciprocal, or cotangent is reciprocal of tangent, so that would be 12 over 35. Okay. So those 3 are really easy to find if you keep them lined up with their reciprocal, and then you can just take the reciprocal of that.